Hey guys, now we're on lipids. Lipids include a diverse group of compounds that are largely nonpolar in nature. This is because they are hydrocarbons that include mostly nonpolar carbon-carbon or carbon to hydrogen bonds. Nonpolar molecules are hydrophobic. That means water-fearing or insoluble in water. This also means fat is mostly insoluble in blood. All right, the word hydro, or the prefix hydro, means water, and the suffix phobic means fearing. Lipids perform many different functions in cells. One of the most important functions is for storage for long-term use in the form of fats. Think of blubber on a whale. All right, that's how it stores. It is a storage for long-term use. And then lipids also provide protection from the environment. In one way is impact, that is, if you get bumped on your face, right, that subcutaneous fat helps to protect you from your own bones so that your bones don't pop through the skin. And then, of course, insulation in terms of body fat. Lipids are also the building blocks of hormones, primarily the hormone that is, cholesterol. Cholesterol serves as kind of like the backbone of almost all hormone production. Lipids are an important constituent of all cellular membranes. Lipids include fats, oils, waxes, phospholipids, and steroids. A fat molecule consists of two main components: a glycerol backbone. Glycerol is an inorganic alcohol with 3 carbons, 5 hydrogens, and 3 hydroxy groups. Glycerol is an organic compound. It's actually an alcohol with 3 carbons, 5 hydrogens, and 3 hydroxyl groups. The hydroxyl group is actually a OH group. All right, these are fatty acids. Fatty acids have a long chain of hydrocarbons. All right, the number of hydrocarbons in the fatty acid may range from 4 to 36. The most common are those containing 12 to 18, and fats are a required part of human nutrition. Okay, so the glycerol molecule is here. You'll notice that it has 3 carbons, and it has a a series of hydroxyl groups here. 3 carbons, hydroxyl groups, and each of these hydroxyl groups is going to hold a glyceride molecule, or a fatty acid. And here we see a fatty acid, and the fatty acid is a hydrocarbon chain, and you'll notice that it's a straight chain. All right, that is, the carbons all have 4 bonds, and it forms a very straight molecule. So here we have a triglyceride. That is, there are three of the fatty acid side chains, making it a triglyceride. Fatty acids may be saturated or unsaturated. In a fatty acid chain, if there are only single bonds between neighboring carbons in the hydrocarbon chain, the fatty acid is saturated. Saturated fatty acids are saturated with hydrogen atoms. In other words, the number of hydrogen atoms attached to the carbon skeleton is maximized. Here you see a saturated fatty acid. So each of these carbons has 4 bonds, all right, and it has as many hydrogens as it can possibly hold. That's why we say that it is saturated with fatty acids. And that keeps this thing very straight. We'll talk about that in a second. Long, straight fatty acids with single bonds generally pack together tightly and are solid at room temperature. So these guys are nice and straight, and they will pack together very well at room temperature. Animal fats with stearic acid and palmitic acid, common in meat, and the fat with butyric acid, common in butter, are examples of saturated fats. Mammals store fats in specialized cells or liposomes, where fat globules occupy most of the cell's volume. Unsaturated fats or oils are usually of plant origin. The double bond causes a bend or a kink that prevents the fatty acid from packing together tightly. So right here we have this double bond, and that's what causes this kink in the fatty acid. And it's not going to pack nearly as tightly as these guys up here. Unsaturated fats or oils are usually of the plant origin. The double bond causes a bend or a kink that prevents the fatty acid from packing together tightly, keeping them liquid at room temperature. Olive oil, corn oil, canola oil, and cod liver oil are examples of unsaturated fats. Unsaturated fats help to reduce blood cholesterol levels, whereas saturated fats contribute to plaque formation in the arteries. So, excuse me, these guys here, they tend to be good for us because they don't pack together tightly, whereas these guys pack together tightly and they clog up our arteries.